Hello again, everyone. This is Shane, and welcome back to another math video. Today, we're going to be talking about quite a few new vocabulary words, right? The first word we're going to talk about is called the discriminant. Discriminant, right? And I'm going to explain what that means in a few. But the way I'm going to approach this lesson is I'm going to explain a few things first, and everything here should be just a little bit of a review. So let me know if I'm moving too fast, right? So the first thing I want to talk about is a polynomial, right? Now, a polynomial is a mathematical expression made up of numbers, variables, and exponents, where exponents are whole numbers, right? One, two, three, etc., even zero. And the terms are added or subtracted. So here's a simple example of a polynomial, 4x squared plus 9, for example, right? Just a mathematical expression made up of a number of mathematical terms. This is one term, that's another term. So there are two terms here, all right? Now, more words we're going to talk about. We classify polynomials based on a word called degree and the number of terms, right? So we're going to talk about what a degree is. Well, a degree is the largest exponent on any variable after the polynomial has been simplified, right? So uh, we're going to look at a few examples. I'm just going to go through some of the notes that I have here. What I have here is just a general example of what a mathematical term may look like, right? Ax to the n, where n is your exponent, x is your variable. Your variable could be x, y, z, a, b, c. It doesn't matter, right? As you know, a variable is just a letter or symbol used to represent an unknown quantity. And a number that is multiplying a variable is called a coefficient. If a number stands alone, then it's called a constant. So, for example, 3x squared plus 4, this 4 here is just a constant. It's a term by itself. Here's the trick. It also has a variable, but the exponent is 0. And I'm running through a few things here because I do believe that a lot of this should be review for you guys. So, if a polynomial has a degree of 1, we say that that polynomial is linear. If it has a degree of 2, we say that that polynomial is quadratic. And if it has a degree of 3, that polynomial is cubic. All right. Again, a lot of new words. Pause the video if you need to. All right. So we have linear, quadratic, cubic. All right. Um, Here are a few examples. So if you should look here, 3x plus 2, this has an exponent of 1. And remember, I'm going to slide back right here. Let's read what a degree is. A degree is the largest exponent on any variable after the polynomial has been simplified. We have to put this part in there because sometimes we have like a polynomial with like terms, right? For example, so 3x squared plus 2x squared can be added together to give us 5x squared plus 4x. So ideally, it's just saying simplify the polynomial first, then you look at what the degree is. In this case, the degree is 2. It is the largest or highest exponent. Okay, so if you should look here, technically, every constant has a variable that's raised to the exponent of 0 because anything raised to the power of 0 is just 1, right? So 2x to the power of 0 is just 2 times 1, which is just 2. So basically, because the exponent here is 1, we say that it is linear. Every linear polynomial or function can be represented or graphed by a straight line. Okay. Now, examine my second example here. the highest or largest exponent is 2. And what we said was if the exponent, the highest exponent is 2, then that represents a quadratic. And every quadratic, every single one, can be represented by what is called a parabola. Parabola, parabola, right? And parabolas open up or open down, okay? And then look at my third example. My highest exponent here is a 3, which means that it is cubic. And as you can see, this is what a standard cubic graph looks like, right? These are standard graphs. And in mathematics, especially when you get to algebra 2, etc., you're going to learn about what's called the library of functions, or we call them parent functions. These are the first three, right? Well, there's another one called the identity function, but which is simply just a horizontal line. But in any case, we have the linear function, the parabola, and the cubic function, right? Represented by quadratics, etc. Now, a quadratic function is what we're going to be zoning in on a little bit. And remember, it is quadratic if the highest exponent is a 2. Now, if we should look here, we're going to be looking at some quadratics. But before we do that, I want to show you what's the standard form of a quadratic function. Ax squared plus bx plus c. This is the standard form of a quadratic function. The basic form is just x squared, as you can see there, right? And so what I want to look at is I'm just going to slide over to Desmos, and I'm going to just look at a few things here. So x squared, this is how a parabola looks. As you can see, basic parabola, okay? If you could look carefully, it basically is a parabola that opens up. Let's do another one. Let's go with x squared again, but let's make it negative, and then you can see this one opens down, right? Pretty standard stuff, pretty standard stuff. Now, what I want to talk about, right, is, let's go back here. What I want to talk about is number of solutions to a quadratic function, right? So when talking about number of solutions to a quadratic function, this part is the important part. So when talking about real number solutions, a quadratic function can have three possible outcomes. You can either have two real solutions. This is represented by the parabola crossing the x-axis in two places, right? One real solution, this is where the parabola touches the x-axis once, and this is referred to as a double root. Or we can have no real solution, and this is when the parabola does not touch the x-axis, right? Now, what I want to do is I want to sketch some graphs in Desmos just to show you what this looks like graphically, right? So let's go to Desmos here and look at this one here. I'm just going to graph this. So 4x squared minus 2x plus 7, okay? So look at this one here. What I want you guys to pay attention to is this. Our x-axis is down here. Can't write on the screen. It's not moving. But if you notice, this graph only intersects the y-axis, not the x-axis. So this parabola, we would say, has no real solutions, right? So what I want to do is I'm going to do some simple ones, and I want you guys to just pay attention to the simple ones. So let's go with x squared plus 4. Okay. With x squared plus 4, right? what do you notice? Um, let's zoom out. What do you notice about this one? X squared plus 4 does not cut the x-axis any at all. This one we would say is no real solution. It does not cut the x-axis, right? How about then x squared minus 4, right? Look at this one. Do you notice? This one cuts the x-axis at -2 and +2. -2, +2. So this one we would say has two real solutions, right? Okay, how about, let's try this one here. X minus 2 squared. Let's look at that. Look where this touches the axis. It touches the axis at one point. This is where we say this has one real solution. So I hope you guys can see that, right? Let's look at a few more so that you can see. We just examine a couple here. Let's go with x squared. Do you notice I always start with x squared? That's because it's a quadratic. X squared minus 2x minus 3. Check it out. Cause the x-axis here and here. So this is what we would say are two real solutions. And you can see what the solutions are. -1 and 0, 3 and 0. Okay, well, let's examine another one then. Let's examine x squared, right, minus 6x plus 9. It's a perfect square. Here we go. What do you notice? This touches the x-axis only once. So this is what we would say is one real solution. All right. And then last one, let's go with x squared minus 4x plus 8. What do you notice? So do you see? It doesn't cut the x-axis. So this is one where we say has no real solution. However, what's important is that we understand that no real solution doesn't mean that a parabola or quadratic doesn't exist. It just means that it does not cross or interact with the x-axis. Awesome. So next part of the lesson. All right, going a little quickly, but you remember here. So what I want to do now is I want us to be able to identify A, B, and C from a quadratic, right? As you notice, I was typing out different things in my in Desmos. So let's look here. 4x squared plus 9x plus 6, right? The trick here is that we must be able to identify A, B, and C. Now remember, let's go back up here. With the standard form of a quadratic, ax squared plus bx plus c, a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant or the coefficient of the x to the power of 0, right? But you could just think about it as the constant, the number that stands alone, okay? Just remember that. So let's look at a few examples. So in this case, a would be equal to 4, b will be equal to 9, c will be equal to 6. All right, what about x squared minus x plus 1? Tricky one. A would be equal to 1 because it's the coefficient of the x squared term. And so if a variable is by itself, what do we assume? That it has a coefficient of 1. B will be equal to -1. C will be equal to 1. I like to throw that in there just because. All right. How about this? 9x squared plus 2x. I like to throw these kinds in there because you can see a few things. A will be equal to 9, B will be equal to 2, and what will C be equal to? C will be equal to 0, right? Technically, there's like a hidden term there that's called 0x to the power of 0. It's kind of funny, but, it just means that, C is 0, right? This is useful in some of the stuff that we're going to be doing shortly. I think that basically covers identifying a, b, and c, just remember that it's the coefficient, the number that's multiplying the variable, because sometimes we are tempted to include the variable, right? So if I say 3x squared plus 9x minus 2, some people say a is equal to 3x squared, right? And b is equal to 9x. That's not correct. A, b, and c are variables, not, I said that incorrectly. A, b, and c are coefficients, not variables. Very, very important. Okay, so now that we've done that, I can now talk about what the discriminant is. All of this has just been laying the foundation. So the discriminant, right, is the part of the quadratic formula. That's something else we're going to touch on shortly. That's under the square root sign. It tells us how many solutions or roots a quadratic equation has without you needing to solve the whole equation. Now, remember when we were looking at Desmos earlier, we could graph the function and tell, oh, it's one real solution or two real solutions, etc. The discriminant is a part of the quadratic formula that allows us to do that without graphing it, right? So here's a quadratic formula. I'm going to be doing another video on this shortly, so stay tuned for that one. The quadratic formula is x is equal to negative b plus or minus the square root. This is the square root in question. And underneath the square root, we have b squared minus 4ac. And all of that is divided by 2a. So the first thing that I want us to pay attention to is that the discriminant is everything that's under the square root, b squared minus 4ac. The second thing I want us to pay attention to is that the entire formula has a, b, and c. That's why I just focused a little bit on being able to find a, b, and c. Very, very important, right? Now, here is the rule for the discriminant, and this is just kind of notes, right? If when you calculate b squared minus 4ac, if you get a positive number, then it means that we have two real solutions. If you get it being equal to 0, then it means that we have one real solution. And if we get it being a negative number, it means we have no real solution. And remember, no real solution means that it doesn't cut the x-axis, right? One real solution means that it's like on the axis itself, and two real solutions mean that it cuts the x-axis twice. All right. Now, I think that's the end of that part. Let's do some examples. All right, so we're looking at a few examples here. I really don't need to do too much for this, right? I just want to show you guys the best practices for doing it. So the instruction says, find the discriminant. Do you see that? Of each quadratic equation, then state the number and type of solution. Okay, so let's look at it together. So with question number 1, my first step is to identify A, B, and C. All right, so A will be equal to 6, B will be equal to -5, C will be equal to 1. Okay, now that's our first step. So our second step is to write the formula. B squared minus 4ac. The way I'm going to be doing it is by doing the best practice. So what's the best practice? Okay, follow. Parentheses 4ac. That's how I set it up. So b squared goes in here, a goes here, c goes here, right? So let's do the same thing. And I think, don't follow what I just did there. Nonsense. That. There you go. So that's b squared minus 4ac. So b in this case is -5. and then A is 6, C is 1. Now, using your, if you do it this way, you can actually put the entire thing in your calculators, but let's not do that right now. Let's take our time. Negative 5 squared is positive 25 minus 4 times 6 is 24, right? And 4 times 6 times 1 is still 24. And I end up with just 1, okay? And because this is positive, this means that I have two real solutions, right? Now, a thing or a mistake that people tend to make is when the 4 times the 6 times the 1 is there, some persons will go 4 times 6, 24, and then they'll do something like, let me use another one because the one is this one's easier. So 4 times 6 times, let's say 3. They'll go 4 times 6, 24, and then 4 times 3. All right, so they go 24 and then times 12. And they do like a double multiplication. Please don't do that. Okay. I don't like to focus on bad habits. So I just know that that's a mistake that people can make. You don't FOIL multiplication. Multiplication is commutative. So 4 times 6 times 3 is literally 4 times 6, 24 times 3, and you multiply it like that. Okay. Now, and you just multiply the numbers together. That's important. Okay, so let's look at another one here. A is equal to negative 5, B is equal to negative 6, C is equal to negative 6. The discriminant is B squared minus 4 AC. So I do this. So B is negative 6, A is negative 5, C is negative 6. Now I put this example in there because this is one that can get tricky, where you have to remember some key things algebraically. First, negative 6 squared is positive 36. Now, the key to it is that you can do this part here a few ways, right? This tends to throw some people off. The way I see it is if I have three negative signs, then it means that I'll end up with one negative sign because two negative signs cancel each other out. That's one way to look at it. Another way to look at it is to leave, let me erase this part here, to leave this negative sign, to carry it down, negative, and multiply 4 times negative 5 times negative 6, like this, right? So you end up with 36 minus, and then you multiply 4 times 5, right? And then you multiply that times 6. So you end up with 120, and a negative times a negative is a positive 120, like that. And then 36 minus 120, I think, subtract 30, and then 6, you get negative 84. Now, if you put this entire expression in your calculator like this, once you put it in like this, making sure that with your Texas Instrument, you use, so the Texas Instrument has like a minus sign, and then it has a plus or minus sign. This one is negative, this one is minus. So as long as you make sure that the minus sign is what goes here, and the negative, like the plus or minus sign, these are negatives, right? As long as you use the right thing, you'll get the right answer. If you use a big minus sign instead of a negative sign or vice versa, it will throw it off sometimes. Anyway, so that's just like a some of the best practices here. This would obviously be negative, and as I said before, if it's negative, then we end up with two imaginary solutions, or we would say no real solution, right? So these are just two examples highlighting the focus here. I think this question definitely covers some of the more complex aspects of manipulating the negatives and the positives, making sure that you put this stuff in your calculators properly or practice your negative and positives properly. Um, as long as you do that, you'll be fine. Okay? Let me know if you need me to do more examples.